effects of parameter a on parabola y equals ax squared plus q. Let us investigate the effect of a on the parabola. Consider the parabola y equals ax squared plus q, where a equals 1 and q equals 0. It becomes the parabola y equals x squared, which we saw earlier. The graph of the parabola can be drawn. We now take the value of a as half. A equals half. Q equals 0. The parabola is y equals half times x squared. We calculate the y values for different x values and tabulate the results. X equals -3. Y equals half times -3 squared equals 4,5. X equals -2. Y equals half times -2 squared equals 2. Similarly, x equals -1. Y equals 0,5. X equals 0. Y equals 0. X equals 1. Y equals 0,5. Let us plot the points on the same set of axes. We join the points with a smooth curve. Observe that the graph of y equals half times x squared is wider than the graph of y equals x squared. We now take the value of a as 2. The parabola is y equals 2x squared. We calculate the y values for different x values and tabulate the results. X equals -3. Y equals 2 times -3 squared equals 18. X equals -2. Y equals 2 times -2 squared equals 8. Similarly, x equals -1. Y equals 2. X equals 0. Y equals 0. X equals 1. Y equals 2. X equals 2. Y equals 8. X equals 3. Y equals 18. Let us plot the points on the same set of axes. -3, 18. -2, 8. -1, 2. 0, 0. 1, 2. 2, 8. 3, 18. We join the points with a smooth curve. Observe that the graph of y equals 2x squared is narrower than the graph of y equals x squared. We can say that the graph y equals a x squared is stretched vertically when a is increased. Here is an increase from 1 to 2. Hence, parameter a causes vertical stretching of the parabolic function. When a is decreased, as it does here from 1 to half, the graph becomes wider. Remember that we took only positive values of a in this investigation. All the functions here have a minimum and are open upwards. What if a is negative? If we take a equals -1, the function becomes y equals -x squared. We can draw the graph of this function. It will appear as shown here. -3, -9, -2, -4, -1, -1, 0, 0, 1, -1, 2, -4, 3, -9. Observe that the graph of y equals -x squared is a reflection of y equals x squared about the x-axis. We similarly draw the graphs of y equals -2x squared and y equals -half x squared. Now we see that as a decreases from -1 to -2, the graph is vertically stretched, and when it is increased from -1 to -half, the graph becomes wider. This is the reverse of what happened for positive values of a. When a is negative, the functions all have a maximum and are open downwards. We can conclude that for a greater than 0, the graph of f of x has a minimum turning point at 0, 0. For a lesser than 0, the graph of f of x has a maximum turning point at 0, 0.
Need more help? Subscribe to our channel. Can't wait that long? Ask Maski to help you and let the math finally start mathing.